Okay, this is 2009 FRQ number 6 in the non-calculator portion. The derivative function f is defined by f prime of x equals g of x between -4 and 0, and 5e to the negative x over 3 minus 3 between 0 to 4. So it's this picture right here. The graph of the continuous function f prime shown in the figure above has x-intercepts at x equals -2, so that's 0, and x equals 3 natural log of 5/3. Awesome. The graph of g on between -4 to 0 is a semicircle, so we know for sure it's a semicircle, and f of 0 equals 5. So this is my starting point. Okay, so we'll talk about that. We'll use that soon. All right, between -4 and 4, find all the values at which the graph of f has a point of inflection. Justify your answer. So for f to have a point of inflection, f double prime must equal to 0. So we're looking for f double prime equals 0. Well, this is a graph of f, which means I'm looking for the slope of f prime equals 0. So when is the slope equal 0 on this picture? Well, slope is 0 at -2 and at 0, right? Because that's the slope of 0 and the slope of 0. That is not a slope of 0. That is a value of 0. So we have a slope of 0 at those 2 points. So at x equals -2, x equals 0. Okay, so which one is truly a, well, let's see if they are truly points of inflection. Because in order for it to be a point of inflection, your double prime has to change from positive to negative, which means the slope has to change directions. So at -2, before my slope was decreasing, and now it's increasing. So it changed from negative to positive. So slope of f prime, let me move up here. Slope of f prime decreasing changed to increasing at x equals -2. And then at 0, you went from increasing to decreasing, and went from increasing change to decreasing at x equals 0. So these two are point of inflection because the concavity did change, right? So the slope did change, therefore the concavity changed, therefore they are truly point of inflections. All right, part B. Okay, find f of -4 and f of 4. Okay, so f of -4. So how is f defined? Because this is f prime, right? So f is defined as 5, because you start with 5, plus the integral of your f prime. So depending on what you want, between 0 to whatever x value you want. So whatever x value you are looking for. All right. So if we want f of -4, sorry. So f of -4 means that it's 5 plus integral between 0 to -4 of f prime. Okay. So 5 plus, okay, I want 0 to -4. Well, first of all, this is in the wrong order. We always want low to high, not high to low. So in order to flip that around, we got to change it to a minus, right? So minus -4 to 0 f prime. Well, -4 to 0, that is a semicircle. And I really want this piece right here. So that piece is really a rectangle minus a semicircle, right? So it's going to be 5 minus the rectangle of 1, 2, 3, 4, 4 units by 2, so 8 minus semicircle, so pi, radius of 2, pi r squared over 2. All right, so that is going to be 5 minus 8 is -3 plus 2 pi. So I'll clean this up, 2 pi minus 3. That is the value for f of -4. All right, for the value of f of 4, we want 5 plus integral 0 to 4 f prime. All right, so we want that integral instead. So now we want the integral from 0 to 4, 0 to 4, right? Now, good thing is we don't need to figure that out geometrically. We have the function here. So we can actually use the function. This is the equation between 0 to 4. So you actually have 5 plus integrals between 0 to 4 of the function 5e to negative x over 3 minus 3 dx. All right. Okay, so now this is calculus. This is what we've been doing. Right? So 5 plus, all right, the n-hat derivative of this, you have 5, that's your coefficient. E to the negative x over 3 is still going to be e to negative x over 3. What is the derivative of negative x over 3? The derivative of negative x over 3, negative x over 3, is negative 1/3. That's the derivative. But we want to take it out as a reciprocal. So we take out negative 3. Negative 3 times that is negative 15. Right? And then minus 3, so minus 3x evaluated between 0 to 4. Okay? Let's plug in our numbers. 5 plus, all right, so negative 15e to negative 4/3 minus 12 minus negative 15e to the 0 minus 0. So 5 minus 15e to negative 4/3 minus 12. This is e to 0 is 1, so plus 15. So that gives me 15 plus 5 is 20, minus 12 is 8. So 8 minus 15e to the negative 4/3 is a really gross answer, but that is our answer. Okay, part C, between negative 4 and 4, find the value of x at which f has an absolute maximum. So f has an absolute maximum when f prime is equal to 0. In the problem itself, it says that x equals 0 at x equals negative 2 and x equals 3 natural log of 5/3. Well, x equals negative 2, for something to be truly a maximum, you want the f prime to go from increasing to decreasing, which means the f prime needs to change from positive to negative. In our picture here at x equals negative 2, our f prime graph stayed positive to positive. So that means this is not a maximum. So the only other true maximum will be this one, where the graph went from positive to negative. Also, if you take a look at the function, the graph itself is positive. The f function, the graph is defined as area underneath the curve in the x-axis. So all the way up to that point of 3 natural log 5/3, you have positive area the entire time. So you're just adding to the 5 that you started with. So you're going to be have the largest value at that point, because after that you now have a negative piece right here. So that tells me that you are going to have absolute, this is part C, absolute max at x equals 3 natural log of 5/3, right? Because f prime changed from positive to negative, creating a max, and f prime is positive before x equals 3 natural log of 5/3. That means f has a positive value, right? So then that means that even if you check the endpoint at f of negative 4 when you start it, it's going to be less than what you have right now. So this is truly the absolute maximum at x equals 3 natural log of 5/3.